welcome back to my channel, and this is for the love of chemistry. Here we make chemistry simple, easy, beautiful and exciting. Okay, so today we are going to look at something that I've promised you I was gonna do, because the last time we were working on gas laws, we saw that some gas laws involve calculation of molar masses. So today I'm going to look at the calculation of molar masses, because I know some people were busy doing everything except what they should be doing while this was being taught. I'm not judging you here. We don't judge, we just help. We don't judge, we help. So I'm here to help you to understand any form of calculation under molar mass. We are good. But before I dive into that, the last time I asked a question regarding which gas law states that equal volume of gases at the same temperature and pressure contains the same number of mole. Someone from TikTok answered Avogadro's law, and he was correct. The name of the person is K-Shaik. I don't know if I pronounced it well. So K-Shaik, if you are watching this video, please send me your phone number so I can send you an airtime token. All right, so let's go right into today's video, and here we have find the molar mass of copper 2 tetraoxosulfate 6. So when you are asked to find molar masses, what it entails is that you add the individual atomic mass of the elements that make up the compound. What do I mean? It's given. The atomic mass of each compound is given. It's not what you have to solve to get. It's given, because some of them is not even the protons and number of protons and neutrons are not equal. So you can't say that you will multiply the atomic number by 2 to get it. Some of them, they have fractions. Some of them, they are odd numbers. So you see that the atomic mass is given. That is why if you look to the other side of the board, you can see that I listed some atomic masses. But our concern today is how to calculate the molar mass. Okay, so the molar mass of copper 2 tetraoxosulfate 6. Now let's see. Like I said, in calculation of molar masses, you have to add the individual atomic mass. That's one. But in a situation whereby you have something like, look at this, oxygen has 4, showing that it represents 4 atoms of oxygen. So whatever the mass of one atom is, you have to multiply it by 4. So let's look at this. So the molar mass of this will be copper has an atomic mass of 63.5. So we say 63.5 plus sulfur has atomic mass of 32 plus 32 plus oxygen has atomic mass of 16. But we have 4 atoms of oxygen here. So we multiply 16 by 4. The reason you have to put this in brackets is so you don't mistakenly maybe go and add 16 and then use 4 to multiply everything. You will make a mistake and you will fail it. And remember your board mass in your primary and early secondary school, you always do multiplication first before addition and subtraction. So 63.5 plus 32 plus this time this will give us 64. And when you add that together, I don't have my calculator here, you have 159.5. Yes, this is in grams, but it is gram per mole. This is the gram for 1 mole of this substance. So the unit is gram per mole. I hope that makes sense. All right, so let's look at another molar mass that we can find. Question number 2. Let's find the molar mass of calcium hydroxide. All right, so look at this now, we have the atomic mass of calcium here, we have the atomic mass of oxygen, and we have the atomic mass of hydrogen. Now, if we are to do just like I have said earlier, calcium has atomic mass of 40 and it's just one atom of calcium here, so we add just 40. And then oxygen, which is 16, but this bracket shows that there are 2 atoms of oxygen and there are 2 atoms of hydrogen. And if you remember when I told you about radicals, this OH is a hydroxyl radical. It acts as a single unit. That is why the valency from calcium was given to it as a single unit. That's why you have it in brackets. To indicate that each of the atoms, there are 2 of them. So here we have 2 atoms of oxygen and 2 atoms of hydrogen. So since oxygen atom, 1 atom is 16. 2 will be 16 times 2 plus. Remember, you are adding the masses of each atom that make up the molecule or compound. So hydrogen, you have 1 times 2. So 40 plus 32 plus 2, which will give us, that's 74 gram per mole. That's